All right, folks, last part of this section of 5.5. In fact, this is the last video for this unit of 5.3 to 5.5. So we're going to do a little bit of practice, but just be careful because it kind of puts everything together. The rules you learned today are going to be really important to have somewhere safe so you can look back at them. Integrating, just a reminder that usually when you integrate with e to the x, same thing with the derivative, the integral of e to the x is literally e to the x plus c, but what you're really doing is e to the x times 1 over ln of e, but again that cancels because that's 1 plus c. So here we're going to do a to the x, but times 1 over the ln of whatever your base is, plus c. Again, you didn't have to worry about that with e to the x because, again, 1 over ln of e is just 1. So this adds a slightly different layer, but hopefully you'll be okay with that. All right, so we're going to put this into action. The integral of 2 to the x is going to be 1, or actually you could do 2 to the x first, but you have to do times 1 over the ln of 2 plus c. And again, you can leave it like that. If you want to clean it up a little bit, you can, and do 2 to the x over ln of 2 plus c. You can. It's up to you, but if that works for you, feel free. Notice this one's a little different because our exponent here is not just x. So you have to use u substitution. Okay, so u would be 3 minus x squared. Again, this shouldn't feel very new to you because we've done this a lot, but du is going to be 2 times 3 minus x to the first, but then don't forget to multiply by the derivative of the inside, which is actually negative 1 dx. So this is really negative 2 times 3 minus x dx. Okay, so we're actually integrating 7 to the u du, but we have an extra negative 2 in here that I need to take out. Right? I need to factor that out. So before I integrate, that's what it looks like, and then I can now actually integrate. So this becomes negative 1/2 7 to the u times 1 over ln of 7, because that's our base here. And then we have our plus c. And then all you have to do is clean up a little bit. You can do it at the same time, though. And then plug in what u is. So now we have, I would actually make it like negative 7 to the 3 minus x squared over 2 ln 7 plus c. So it looks not super clean, but it's compact, which is helpful. All right, one more. So now we are definitely integrating. We're using the definite integral. Sorry, terrible. Again, bad teacher humor. I want you to see if you can try this one. Just a reminder that you're integrating like normal, but this time at the very end, again, you're plugging in 1 and 0 and subtracting your answers. So try to find the integral of this on your own. It's not that hard because these are both raised to the x. Just be careful of the subtraction sign in between. All right, guys, check the work I showed you. So just a reminder that your integral of these separately is 6 to the x times 1 over ln of 6 minus 2 to the x times 1 over ln of 2. So make sure you plug in the 1 for both. 6 to the first is just 6, 2 to the first is just 2. And then remember 2 to the 0 and 6 to the 0 are both 1. I don't know why I wrote that. That should have been 1 over ln of 2. Anyway, when you plug that all into your calculator, hopefully you got that. Okay, so next one, they're asking you to find the area of the region bounded by the graphs of the equations. Again, we've done this a little bit, but now we're throwing in some different stuff slightly here. The last few that we're going to do today are actually application problems, which is the reason why we really do these. But I'll try to go a little slower through them because they're kind of new to us-ish. There's a little bit of review, but not a ton. So just a reminder, if you are finding the area bounded by the regions, you're integrating between 0 and pi here. for 3 to the cosine of x, sine of x. Okay, so if you're integrating that, you are going to have to use u substitution here. I'm going to have you try this one. Hopefully you'll get the same answer as me, but again, I'll have you unpause and see the work in a second. All right, guys, I got about 2.427, so hopefully you got something around that as well. Your u should have been cosine of x, your du is negative sine, so you have to factor out a negative here. Just be careful of that. Integrate 3 to the u, which turns into negative 1 over ln of 3 times 3 to the u. Throw that u back in, and then plug in pi and 0, and subtract. It turns into addition because this was negative, so minus a negative. All right, guys, last type of questions are our applications. So just a reminder that if you deposit money at a regular rate, if it's compounded quarterly, monthly, or continuously, you have different formulas there. So quarterly and monthly use the same formula of A equals P times 1 plus R over N to the NT. If it says continuously, that is PERT, okay, A times E to the RT. So for the first one, you actually don't even need to do any calculus, which is very convenient. So this just means you're plugging in, quarterly means 4 as a compounding period. So you're depositing $2,500, which is sweet. If you have that, great. 1 plus your rate, make sure to turn it into a decimal. 0.05 over your compounding period. 2, that's an NT, and it's 5 years, okay? So what ends up happening is if you plug that into your calculator, you end up with about this, okay? Make sure it's in money. If it's compounded monthly, that means your interest actually gets added on more often. 5% is a really high interest rate for a bank account. I get like 0.05, get like a penny a month. But usually banks do monthly, which means our N is now 12. So the only thing that's changing in this problem is now N is 12. Okay, and that means you end up with a little bit more money. Yay. Okay, once you plug that into your calculator, what you'll notice is that banks do not use compounded continuously because you make even more money. So the difference here is now you're plugging in 2,500 times E, so it's like 2.8, to the 0.05, because that's our rate, times T, which is 5. So plug that into your calc, and you should see it's higher. You get 3, 2, 10 point, I think that's a 0.6. Okay, so notice you get a little bit, it's not a ton more money, but over time, that'll increase. So that's why they tend not to use that. This is where the calculus comes in. Okay, it says if the interest rate is compounding continuously, what is the rate at which the amount of money in the account is changing when t equals 3? So if the rate at which the account is changing, that means the slope, or that's right, derivative. Woo. Okay. So we want, first of all, write the formula, right? We have A equals 2,500, E to the 0.05, but we're looking for T, right? Because we don't know what the rate at which the amount of money is changing when t equals 3. So at the moment t equals 3, then we'll know the amount it's changing. So we actually have to find the derivative before we plug in for t. So that turns into, if you take your derivative, that turns into 2,500 e to the 0.05 t times 0.05, right? Because that's the derivative of the exponent. So that comes out to, not 2,500, sorry, 125 e to the 0.05 t. But now we're going to plug in 3 for t, okay? So if you plug in 3, for our time now, think about why we didn't plug in 3 at the beginning. That's right, because the derivative would be 0, so that doesn't make sense. So that comes out to about $145.23 per year. That's actually pretty good. So the rate at which the amount of money is changing, that means it's increasing by that much when you hit year 3, that's pretty good. So I would like that. All right, guys, the last one, very, very similar, except for the very last part of the question. So just a reminder that for the first few, you're just plugging in those values. So they're now talking about bacteria, and they actually give you the equation. Y is the weight of the culture, and then T is time of the hour. So it says find the weight of the culture after these amount of hours, then what's the limit as T approaches infinity, aka what is your ratio. I'll explain the last one in a little bit, but I want you to actually try the first 3. You're just plugging in those values. You can plug them into your calculator. Okay, so hopefully you got 100 grams, 107.06, as long as I'm reading my handwriting correctly, and then 124.4 grams. So you can see the weight is growing, but there is a cutoff point. Some of you who took pre-calc last year actually might remember this kind of formula used before, but just a reminder about if you're approaching infinity, what that means is you're really taking the derivative there, but we're not going to have you do that because that's crazy. It's a lot. So instead, I'm going to have you think about when you have a rational function like this, you want to look at the degree of your numerator and the degree of your denominator. Okay? If they are equal, okay, then you divide the leading coefficients. So I just want to explain why the degrees are actually the same. If you look at the degree of the first one, it's like raising a variable to the 0 power. The highest degree on the bottom, notice this is a negative, is actually still 0 because the 1 is times t to like the negative power. So the degrees are actually both 0 in this case. So you actually divide the leading coefficients of both, and the leading coefficient of your numerator is 125 and 1 on the bottom. So you approach 125. So that means that that's actually the max weight you can get. If you graph it in graphing calculator, it's another way for you to verify that that is the case. All right, guys, have a wonderful rest of your day. If you have questions on any of this, please let me know.